Could all argue that we actually really know a lot about solving quadratics already. And that was evidenced yesterday before we even started our notes for this. You guys were able to solve those quadratics that I gave you like up to 3 or 4 ways. Okay. So one of the other ways that we want to talk about is factoring. And people are going to feel differently about factoring. Some people don't mind it. Some people really dislike it. What I can tell you as an Honors Algebra 2 student is now is the time to buckle down and commit to your factoring skills because it is not going away. Whether you're going to take Algebra 3 or you're going to be in pre-calculus, if you continue on in math, which you are going to, you are going to have to factor. And so the sooner you figure this out, the happier of a math student you're going to be, and we all want you to be happy. So solve equations by factoring. So we're going to talk about factoring on the next slide, but first we want to talk about something called the zero product property, which I mentioned in at least one of my classes yesterday. I'm not sure which one. But the zero product basically, or zero product property basically says this. If A, I'm going to make it capital A. If A times B equals 0, so if you know two things are multiplying together and equal 0, what do you know about one or both of those things?
0.
One or both of those things equals 0. Okay? So if A times B equals 0, then A equals 0 or B equals 0 or they both equal 0. Okay? But at least one of them has to be equal to 0. So that's why solving by factoring works. Okay? So you can solve by factoring if you can get two factors that are being multiplied together. We talked about this yesterday in our warm-up. You set your factors equal to 0 because if one of those factors was 0, then the whole thing would be 0. So that's why that works. I would also maybe make a little note just here at the beginning of your notes. Solve by factoring. You're going to hear me say this a lot. If you're looking at an equation that has two kinds of x's, so these are not like terms, so they're different types of x's. There's an x squared and an x. If you have x squared and x in an equation, the best method, sometimes the only method for solving, is going to be factoring. So we'll see some where they are unfactorable and we'll have other methods available to us. But if you see x squared and x in the equation, then you have to factor it. If we go back to our warm-up or your homework assignment from yesterday, where we're solving by taking square roots, notice in this first equation, I do not have x squared and x. I have only x squared. So I can peel away the layers, isolate the x, and solve. Here, I have one kind of x. Okay? As long as we don't multiply this out, x minus 4 times x minus 4, then we'll create two types of x's. But if we just undo the things that are happening, like that square root up there, okay, then we're going to be able to solve for x. Okay? But if you have x squared and x in an equation, you'll have to solve by factoring for right now. So, I now have this question to pose to you. How do you factor? And this is the hardest part about being in Honors Algebra 2. And we're coming from different middle schools, different algebra teachers, different experiences all around. Yeah, different backgrounds. We're a diverse bunch in here. Okay? So we've maybe been taught to factor differently. So I want you to kind of brainstorm some ideas within your groups. If anybody knows how to factor, describe to your group how to factor. If you know some tips or tricks, you can share those with your group members. If you know some specific special patterns or rules, you can share those as well. And then we'll kind of come together and see, as a whole, as a class, what we could do to factor. So I'm going to give you a little bit of time with your groups. I'd maybe jot these down just as examples of factoring in your notebook. Extra examples. Go ahead, jot them down and talk to each other. Isn't it?
Like factors and forces. So like, I know like Two numbers and ask you for 14. And you add those two numbers and ask you for 5.
It's whatever the sign is.
So
Oh,
this
yes,
would be negative
isn't it
7.
making
It'd be 2 negatives.
Oh, I'm gonna add another one too. I just thought of a good one I should put up there.
Anyone else here with the triangle?
Maybe.
We had to like finish one triangle again. Like the top of it was the number that we were doing up for me. Squared. If you were foiled.
What should I make this last one?
X squared.
Or reasonable
I don't know what the
Made this square. Ah,
I mean it's a question.
There's no X.
I don't like
It's an addition symbol, then they'll both be the same.
So like, which one did they want to be to add?
The middle one is the X.
The X is the adding one.
Yeah. I think the C
I
is
don't know how to do the ones with the number 4 that's squared.
I think you're always gonna have X.
Wait, no, it's fine. But. You can't get like
different types of stuff.
7 times 2.
You don't know how to do it?
Like 7.
Negative 7
Yeah.
times 2.
Because are you supposed to do like the factors of 62?
So then the actual like
So then.
equation would be X minus
But what's the trouble?
Oh,
What else is different? What else is different about?
I know. Well, it has different
Yeah.
And then maybe like the third one, like you just want to try and get the X by itself. Like you divide by 2.
Well,
So the X is
let's
zero.
let's
You need to add a zero. So multiply, then you get back. I like it.
It's usually
That works, right? Since there is no just point out X, we would give me 0 because there is 0 X. I do that.
what times what can get you 25?
Is that negative?
No more than a half, you get negative 25. Now what is 25 plus 5?
No, I was saying it's right. For saying you have to have it as a zero.
Yeah.
Oh, I have heard that. I heard it too.
Yeah.
Okay. We're gonna start talking, okay? Okay, I'm gonna put this question out to the class. Are there some that are easier to factor?
Yes.
Okay, so walk me through what's an easy one to factor, Rihanna?
I think the easiest one is
X
x squared minus 25.
squared minus 25. What's your rule or method of operation there?
Well, to negative 25, so you'd probably use 5 times negative 5.
Okay, so you think about it in your head almost like a trinomial, right?
Yeah.
Okay, so then factors of negative 25 that combine to make 0, and you want the opposites. Okay, I agree with that. So, does anybody know what that's called? That factoring? It has a special name.
Difference of perfect square.
Difference of perfect squares.
Difference of perfect squares. So that works like if you have x squared minus 1, x squared minus 4, x squared minus 9, x squared minus 16, x squared minus 25, x squared minus 36, right? All those numbers that I'm putting on the back are perfect squares. Okay. It doesn't work right now for like x squared minus 5 because there are no factors of 5 that cancel each other out because it's not a perfect square. Okay. So that's called a difference of perfect squares. What does difference imply? Subtraction. All right. Okay, good. Okay. Are there any others up there that you thought were easy to factor? Aiden?
Well, I thought the first one was easy, but
Okay.
it's hard to explain.
Oh.
That's fair.
Yeah.
Do you want to give it a go?
Yeah, sure.
Okay.
Oh, okay. Well,
Is
he's
that
gonna
okay?
get up.
No, you didn't go sit back in. It's never.
Red light.
Okay. So there's a minus, so that means you're gonna have a minus and a plus, and then there's a minus over here. So the minus is gonna be the bigger number, and 14. The factors are 7 and 2, and 7 minus 2 is 5. So it'd be the bigger number would be 7.
Good job.
Great job. I couldn't have said better myself, so I'm not going to say anything more about it. Like?
Yes.
Okay. Are there any other easy factorings up there? Kaylee?
The third one is easy, like once you realize the steps you need to do.
Okay, tell us more about what you realized.
So we realized that the only difference between like the third one and the first one is you just have to take off, like divide the two, because there's a common multiple of 2 for each of them. If you divide x squared by 2, divide 12x by 2 and 16.
Now, I'm going to say that like you're not really dividing because like it's not an equation yet, right? So we can't like divide by both sides. We can't make it disappear because it's there, but you can factor it out.
And so then you'll just put 2 outside of parentheses when you're creating it again.
So yeah, I call that factoring out a common monomial. There's one term that they all have in common. In this case, it happens to be 2, so we could take 2 out of everything. And then you're saying after that,
After that, you just do the same thing that you would do with the first one. And you just can't forget about the 2. So it'll be 2 times x minus 4, and then parentheses x minus 2.
okay, great. Thank you, Kenny. Okay, good job. All right, so yeah, sometimes they look worse than they really are, and they're not so bad. Okay.
So that means that the next 2 aren't that hard. Well, the last one's the hard. Oh wait, no, never mind.
Last one's easy.
The last one's easy. The
Kaylin?
second one. Do the other ones have divisions?
Oh,
Fred, Billy, and Joseph.
the top 2 at the top and the third? No. I call my factoring method guess and check.
Yeah, same.
Call mine factoring.
Yeah, Aiden's got a really good like method there where he's like you're thinking about okay, this sign is negative in front of the constant, so one has to be positive, one has to be negative. Because the middle term is negative, the bigger number is gonna be negative. So then he's gonna put the 7 there. And so that's not so much guessing, like it's kind of working it out. But like it's always a good idea at the end of factoring to just think if you refoil it, x squared plus 2x minus 7x, that would be minus 5x minus 14. Oh yeah, it is the thing that I said. But I am going to employ guess and check. Like I use guess and check. So no, I don't have a name for that other than maybe factoring.
Mine is kind of guess and check, so you have to guess and check which factors go in and make 5.
Yeah. But I mean, you can also think about it so then you're not guessing them. But
Balance rate.
I would say, Taylor, no, I don't necessarily have a name for those.
Just call them friends.
Okay, so, there was some debate. Some people were saying the last one was easy. What's easy about the last one? You just factor out an X. In this case, it's a little bit different because it only has 2 terms, right? So then all we can do is say, what do they have in common? They have X there, so we're left with X minus 6. And then nothing else factors. I guess I could have made that a better question. X squared minus 4x. What would you do?
Okay, just factor out the X.
Factor out the x, and then you're left with x squared minus 4. Oh, x minus 4. Oh, I didn't. That's not even the one I meant to make. X minus 4. Right? I meant to do this one. Sorry. X cubed minus 4x.
Oh, okay.
Take out an x.
And X
Then
squared
you're left
minus-
with x squared minus 4. Then what happens? No. X squared minus 4.
Yes. So you distribute X
Oh, you did the
Difference of the
squared.
perfect squares.
yeah.
So then you could have factored this one again. X minus 2x minus 4. Okay, so that one would have been cool. We're not going to see that yet. We'll see that in a later chapter, chapter 4 with polynomials. But we're working with quadratics. Okay, so we got one left, right?
That one's hard.
And this is the one that I really call like guess and check. Because the other ones, as long as the a value is 1, you guys do a pretty good job of, okay, what are the things that multiply to make the last term, that add or subtract to make my middle term, and we're kind of like using Aiden's rules of positives and negatives there. Okay. So if I were factoring this one, I just go like this. It's a trinomial, so it's going to be 2 groups of parentheses. What multiplies to make the first term 3x squared? 3x and
Oh.
x. Okay? What multiplies to make the last term negative 10? 5 and 2, one would have to be positive and one would have to be negative. So I can imagine I could put a 5 and a 2, or I could do a 2 and a 5. And I just like check like my outside and inside terms. So on this one it would be 15x and 2x. Will that make negative 7x in the middle? No. Okay. And then on this one it would be 3x times 2, which is 6x, and 5 times x, which is 5x. Are those going to make negative 7? No. Okay, darn it. So it's not 5 and 2. You got any other factors of 10? 10 and 1. So now I can maybe do a little bit of forward thinking here. 10 and 1, 10 and 1, 1 and 10. I'm going to drop in a 10 and a 1 right there. Then I get 3x and 10x. Will that make negative 7x?
Yep.
Yeah. The 10x will need to be negative, so it's kind of like Aiden's rule to make the big number negative, and then this positive 3x should be positive. Which, now I check it. 3x times x is 3x squared. I get a positive 3x and a negative 10x, which gives me negative 7x. And negative 10 times 1 is negative 10. Okay. So again, remember, you can't hide from factoring as we progress. It will not go away in this class, and it will not go away in the next class. So the more time you spend with that, and I know it can be frustrating, especially if you don't get it right away, the more time you spend with that factoring and really honing your skills, the better off you're going to be in the future. And the happier you'll be when you're doing your math. It will be so much easier. Okay, so Now we got to run through a few examples. Well, those were examples of factoring. And like, it's kind of like at the level that we're at on Honors Algebra 2, you have factored before so many times. Algebra, probably 7th or 8th grade math, you factored. Geometry, probably derivative factoring. They're like, I'm not really teaching you how to factor. You already know how to factor. It's like encouraging you to really practice and hone that skill. But I am going to cover how to solve an equation by factoring. Now we have examples of equations. Notice that they're not just trinomials, they have equal signs. Okay, so for the first one, we're ready to solve, right? So important to note, in order to solve by factoring, one side must be equal to 0. So what are our factors here?
7, 5.
X plus 7, x plus 5 equals 0. In order for those two things to multiply to 0, one or both of them would equal 0. So x equals -7 and x equals -5. My second example over on the right, x squared minus 4x equals 45. Ready to factor? No.
Yes. No.
Okay, I will get students who will try to factor the left as x times x minus 4, but then you can't solve that because you're looking for two factors that multiply to make 45. And so you can't use the zero product property like we are. So we want to have one side equal to 0. Now, I always try to keep my x squared positive, so I'm going to move the 45 to that side. If I had a negative x squared, I personally would move it to the other side. Anybody got our factors for x squared minus 4x minus 45?
-9 +5.
-9,
+5.
+5. -9 times 5 is -45. -9 plus 5 is -4. Okay, so x minus 9, x plus 5 equals 0. Set those factors equal to 0. X equals 9, x equals -5. What would these answers be looking like on our graphs? X-intercepts. We're essentially taking something that is in standard form, ax squared plus bx plus c, and turning it into its intercept form, where we see the intercepts, p's and q's. Okay. Last one down there at the bottom. 3x squared minus 5x equals 2. That's your favorite kind. A is not equal to 1, so it presents a small challenge. What are we going to do first? Subtract 2. 3x squared minus 5x minus 2 equals 0. Remember Kaylee's group? When they were talking about that one factoring, the third factoring that looked hard, but then when she figured it out, it was easy. Always check for what Kaylee's group did, which was look for a greatest common factor. Do 3, 5, and 2 share a common factor? No. So this is the one where I'm really going to employ guess and check. Okay, but this one's not too bad because we got prime numbers, right? So what multiplies to make 3x squared? 3x and x. What multiplies to make 2?
1 and 2.
1 and 2. So we have two options. 1 and 2. 2 and 1.
-2 or 2 and 1. 2 and 1.
Okay, so we'll have to be careful here. We need it to be negative. So 1 is going to be negative and 1 is going to be positive. And we need it to make -5, right? So we need a negative -6 and a +1. Now, I'm thinking ahead so I don't have to rewrite that on the smartboard. Okay, so I'm thinking ahead and I'm trying to do that in my head. If that's like too much for you right now, you just put the 1 and the 2 and then you check it and then you move them, 2 and 1 if it doesn't work. Okay, so that you actually have to do the check part of guess and check. Oh, that's a 1x. Okay. Now the other two looked like it could have been 5x, but then they would have both had to been negative, which would have made it a +2 at the end. Does that make sense? So you have to be careful there. And this is equal to 0. So set 3x plus 1 equal to 0 and x minus 2 equal to 0. So we get 3x equals -1, x equals
Negative third.
-1/3. We love fractions, so leave it as a fraction.
I love fractions.
And x equals 2.
So you can leave it as yes, if you want to open.
No, you must write it as
So you
-1
have-
divided by 3.
Okay, nice.
Now, one other thing that I want to clarify, because in your homework tonight it's going to have another set of directions. Okay. Another set of problems will say something like this. Find the zeros of f of x equals the quadratic. So maybe write this down so that you have your directions. Find the zeros of. Zeros is another word for x-intercepts. So the zeros of the functions are specifically the x-intercepts, not the y-intercept, that's not a zero, only the x-intercepts. And what do you know about the x-intercepts? What's true about all x-intercepts? Y is equal to 0. Okay, so when it says find the zeros, find the x-intercepts, set y equal to 0. And in this case, y looks like f of x. So it doesn't come looking like the equation already with all numbers. You've got to sub-zero in for y or sub-zero in for f of x. Okay, so that would look like on this problem, 0 equals 2x squared minus 11x plus 12. Notice I'm not doing f of 0. That would be finding the y-intercept. I'm replacing the y, f of x, with 0. And then solve by factoring. This one, oh shoot, that's odd, so I can't factor out Gray's common factor, right? I would have to do my guess and check. 2x and x. Factors of 12. Well, it'd be 12 and 1 if the a value was 1.
Yeah.
But one of them is going to get multiplied by 2, right?
Yeah.
So if you did like 12 and 1, you'd have 24 and 1. Or 12 and 1, you'd have 2 and 12, which would be 10. 3 and 8, but then use 3 and 4, right? So let's put a 4 and a 3. So that's 8x and 3x. And then they both are negative. That way, negative 3 times negative 4 is positive 12. And the negative 3x and the negative 8x make 11x. Okay. And so your answers here are going to be x equals 3/2 and x equals 4. So those are the zeros, which show up as x-intercepts. All right. So your homework assignments on your gold sheet. If you take a quick peek at your gold sheet, it tells you that tomorrow you're going to have a concept check over 3.1. So we have solved by graphing. We have solved by taking square roots. We have solved by factoring. And tomorrow, at the beginning of class, after we go over our homework, I'm going to give you a short set of problems, very short. Probably take us maybe 5 minutes. And you're going to do those problems and turn them into me. That is going to be in lieu of you turning in your homework for this section so that I can check those problems and give you feedback. I will be putting that in the grade book, so you want to make sure that you practice the homework up to tomorrow so that you prepare for that. Okay? But it's not a high stress situation. It's just an opportunity to figure out what we do know and what we don't.
Can you sign this?
Yep, 1 second.